This video is on absolute value inequalities. We're going to solve these two inequalities, and we are going to graph the solution on a number line. I will write out the answer in the correct notation, but I will also write out our answer in interval notation for these problems. The first step in solving absolute value, any type of absolute value, is to isolate the absolute value. This absolute value has nothing attached to it, so it is isolated. That means we need to check to see if it can happen. This should be a positive number. A positive number can be greater than 5, so this can happen. Now that we know it can happen, let's determine if it's going to be an and or an or. The absolute value is greater than 5, so this is going to be an or problem. That means our graph should actually go in opposite directions, one going to the left, one going to the right. So to write these out, we write out two inequalities. The first one is keep the inside the same and keep everything else the same as well, so greater than 5. The second one, we keep the inside the same, but we have to do the negative version of the outside, so that 5 becomes a negative. But the inequality also has to flip because we are creating a negative on this side, so it will then become a less than sign. And we're going to solve. So we add the 20 to the other side, so we have x is greater than positive 25. And then on this one we add the 20, so we have x is less than 15. This is an or, so it's going to be x is greater than 25 or x is less than 15. So on our number line, we have the smaller number is 15, bigger number is 25. It is going to be open at 15, and we want all the numbers that are smaller than 15 because it says less than. Smaller than 15 will go to the left. So we can shade this. Put an arrow on there to keep it going. At the 25, it should also be open, but we want all the numbers that are greater than 25, so it's going to go towards the right. Put an arrow on there. Now to write this in our correct notation, we start on this side. We have x is less than that 15. It's the same thing we had here. Or, because that would be that union, we want the x values that are bigger than 25. Same thing we had here. This is our solution. The number line is part of our solution, so we do need to make sure we have that. And then our solution is written out in the correct fashion. Now I also want to put this in interval notation because that or means that union. So this one is going off to negative infinity, but it stops at 15. So we would have that open bracket, negative infinity to positive 15, but it would be an open bracket again because it's open there. Union, because it's an or, that's the break. We are uniting these two shadings. It starts at that 25, but it's an open bracket because it's an open circle, and that one keeps going off to positive infinity. So this would be the interval notation for that. On example 2, we want to isolate the absolute value, which the absolute values are gone, like nothing's attached to it. So now we can check, is this even possible? So this value will give us a positive. So what I cover up in my finger, that's supposed to be a positive. Positive numbers can be less than or equal to 4. So this can work. So now we determine what kind of problem this will be. This is a less than, so this is an and problem. That means that our shading should overlap each other. So to write out our 2, we have the original without the absolute value, so it's x minus 3 is less than or equal to 4. Then we'll have the second one, we keep the inside the same, x minus 3. We'll have to have the negative part of the 4. But our inequality also has to flip, so it will be greater than or equal to. And we're just going to solve. We're going to add 3, so we're going to have x is less than or equal to 7. We're going to add 3, so x is greater than or equal to negative 1. We're going to graph this on a number line. We have the two numbers, your smallest is negative 1, your biggest is 7. So it has to work for both of them because this is an and problem. So we can write out the word and. We have a closed circle at -1, because it's closed here, solid, and a closed circle at 7. Now it has to overlap. So we want all the numbers that are less than 7, so going to the left, and all the numbers that are greater than -1, so going to the right. But we want them to match, so they need to go in between the -1 and the 7. So to write our answer in the correct notation, we start with the -1. All of our values are in between the -1 and that 7. All the x's are greater than or equal to that -1 because it's towards the right, but all the values are smaller than or equal to that 7. So that's how we write it in the correct notation. I'm going to highlight the number line as well as the red part. And I also do want to write this in interval notation. Because the interval notation doesn't go off to infinity, it has a start point and a stopping point. So our interval notation will start at that -1, comma, it'll go and it'll continue until it gets to that 7, and then it stops. So that would be our interval notation.